Okay, today we're doing 6.1 notes. It's adding and subtracting polynomials. So we just need to get through some definitions. So I'm going to kind of jump around a little bit. So I want to start right here with a monomial. A monomial is the product of a whole number and one or more variables with whole number exponents. So again, it's the product of a number and a variable. So when you guys look over here to the right, number, variable, and you're multiplying those two. That's why there's no operation written between them, because that means multiply in math. So we are multiplying between them, so this would be a monomial. 14x to the fourth would be a monomial. So would 4x squared. When we add or subtract monomials together, we get this first definition, which is a polynomial. So many, poly means many. And within a polynomial function, it has a degree n. Just know n is the highest power. So this polynomial right here, the highest power of x is 7. Even though it's not the first term we see, it is the highest power is 7. So in this polynomial right here, the degree is 7. Okay. Moving on, the degree of a monomial is the sum of the exponents and the variables. The degree of the polynomial, like I just said, is the degree of the term with the greatest power of x. And then you guys should also know the leading coefficient goes with whatever term is got the highest power. So over here, the leading coefficient would be negative 6x to the 7th, even though it's not written first. If we put it in standard form, which is by powers of x, this one would be first. So our leading coefficient would be negative 6. Alright, so that is what a polynomial and a monomial is. So one more thing we just need to take a look at is this example right here. And it says identify the monomials. So one key thing right here is monomials are single terms. So this guy right here is not a monomial because there's two terms. And then the other thing is it says whole number exponents. So whole numbers are positive. So this is not a whole number exponent. And this right here can actually be written as 7x to the negative 2. So there's two things that make this not a monomial. So first of all, you're doing 7 divided by x squared, which it says you need to multiply. And then also if we rewrite it, it's a negative exponent. So that one is not one. This one right here has a square root. You don't want square roots in your monomials. So the four monomials are this guy. You have a number multiplied by a variable with a whole number. This guy is also a monomial because technically I can multiply it by x to the 0, and even though we don't do that in math because mathematicians are lazy and don't want extra work, x to the 0 power is really 1, so it does work. This works as well because you're taking variables with whole number exponents, and then this one right here. Okay, so let's take a look at the next example. It says write the polynomial in standard form. So standard form means start with the highest power of x. So we have negative 7x to the 4th. That's our highest power. Then we have plus 5x cubed. So make sure that 5x cubed stays positive because originally it was positive. Then we have the x squared. And then we have plus 2. We don't have an x to the first power term, but that's okay. We can just write plus 2 there. Next question says identify the degree, and we've learned that the degree is the highest power, so this is 4. Okay, so highest power, I'm going to write it again just so we know. And then the leading coefficient always goes with whatever the term that had the highest degree, so that's going to be negative 7. The rest of today's lesson is just adding and subtracting polynomials. So this is pretty straightforward. We're going to be combining like terms today. So in order for a term to be a like term, it has to have the same variable raised to the same power. So this one is asking us to add them. So for your first step, I would just write it without parentheses. So when you're doing this with addition, you can just eliminate the parentheses. When we do this with subtraction, we're going to have to change some signs. So now we're going to combine like terms. So 2x cubed and x cubed make 3x cubed. Then we go to the next power, which is squared. So I'm doing circle, square, triangle, which is just a method to keep things alike. So negative 5x squared plus 6x squared. So you have more positives than negatives. So this is just going to be x squared. You can write the 1 if it makes you feel better in front of the x squared. And then we have 3x. There's nothing else similar to 3x, so we just get to write it. And then negative 9 plus 11 is going to give us positive 2. Okay? So that's our answer. We can't combine any more than that right there. Okay, moving on to our next one. We have these guys. So step 1, copy it down without the parentheses. These are not in descending order, but that's okay, we can handle it. When we write our answer, we are going to write in descending order. So I'm going to start with the highest power. So I have 7x to the 5th and negative 9x to the 5th, which is negative 2x to the 5th. Then I have, we have a negative 16x cubed and an x cubed. It's positive. These ones are negative, so negative 15x cubed. And then I'm moving on to my next term, which is the 8x and the 2x, which makes 10x. And then I just have my constant. So I get negative 5 plus 7, which is 2. Okay? So you guys are going to continue working on this right now. So you're going to try it on your own. And then I'm just going to kind of stall for a second so you can try it. Actually pause the video right now. And then I'm going to write the answer right here so that you can check it. So this is the answer that you should get. So I didn't show you guys that entire problem. If you need me to show it to you, then come on up during work time and I'll help you out with that. Okay, I'm going to do the same thing for this one. So looks like we have 2x to the 11th. And so I'll just do this one real quick because I want to talk about it. So as you go through this problem, it's a little... you feel like you might be doing something wrong because you have 2x to the 11th and nothing else is to the 11th power, so you just get to copy that one. Then you go to the next highest power, which is x to the 6th. You just get to copy that one. This one, you get 8x to the 4th. You just get to copy that one. But then we're down to this x, so you have to be careful because you can't just copy all of them. So I get negative 5x and then plus 11. Okay? So that's that one right there. Alright, we're going to move on to subtracting. So this is where we have to be really careful. The kids are going to make mistakes. It's going to be on this guy right here. So you copy your first set of parentheses, but then we need to distribute this minus to everything over here, which means we need to change the signs. So it's going to be minus 5a squared. A negative times a negative makes that a positive. And then we have to distribute that negative to the positive 3. So it goes like that. So just one extra step before we start combining. 4a squared and negative 5a squared is negative 1a squared, or just negative a squared. And then we have 9a, and then that kind of looks like a 9, but it's an a. Alrighty, so now we have 9a. We just did that with the a that looks like a 9, so we have 10a. So the last step is negative 12 and negative 3, which is negative 15 or minus 15, because they're both negative, so it'll stay like that. Alrighty, for the next problem, we're going to follow that pattern. When I give you guys things like this, suggestions that I want you to do, it's really important that you follow them, because I'm giving them to you because of mistakes that kids have made in the past, and I don't want you to make that same mistake. So these are just tools to help you. So right now what I just did is I distributed that negative. This is a 7, and then when I distribute the negative, it became a negative 7. This negative times this negative made that 2x squared positive, and this negative times the 12x to the 4th made that negative. So now I'm going to start combining like terms. I'm going to start with the highest power of x. So we have negative 8x to the 4th and negative 12x. They're both negative. So if they're both negative, you're going to add them together and keep the sign. So 8 plus 12 is 20, and it's negative, so I'm going to keep the sign of negative 20. Then the next term after 4, we would subtract 1, would be an x cubed, so that's that one, and there's nobody else to combine it with, so we can just copy it. If you want, you can even cancel out the terms as you go so you don't get lost. That's a really good strategy as well. Then I have negative 3x squared, and I have 2x squared, which is going to be their opposite signs, so I subtract and I keep the sign of the one that has more. So there's more negatives than positives, and 3 minus 2 is 1, so that's going to be negative x squared. And then the last one is our constants, 12 and negative 7, also opposite signs, so I subtract. 12 minus 7 is 5. There's more positives than negatives, so it's going to be positive 5. And that's our solution for that one. So now we have our last one, which is this guy down here, and we're going to follow the same policy of 28x to the 7th minus 6x to the 4th plus 2, and then distribute that negative. So we get 6x to the 4th minus 5x squared minus 26, and then we're going to combine like terms. Start with your highest power of x. There's no other x to the 7th, so I'm going to write down 28x to the 7th. Then I have negative 6x to the 4th and positive 6x to the 4th, which cancel each other out. That adds up to 0, and 0 times x to the 4th is 0. Then I have minus 5x squared because of this guy right here. And then I have 2 and negative 26. So 26 minus 2 is 24, and I have more negatives than positives. So that's what I have right there. And that's it for today.